So in this video, we want to explore a little bit more about how velocity is the derivative of the position with respect to time. So for the calculus-based courses, all right, the average velocity has the exact same meaning as it does in the lower courses, okay? It is just your change in position over some time interval, okay? It's just whatever your final position is minus your initial position and then divided by the time interval that it took to get between those 2 points. However, your instantaneous velocity, okay, the velocity that, say, a radar gun used by police officers measuring speeds of cars on the highway, okay, those instantaneous velocities are the change in position with respect to your time interval in the limit that the time interval goes to 0. So we're shrinking those time intervals that we're taking our measurements over, we're shrinking those down to an infinitesimally small point, okay? And when we do that, when we have changes in quantities as the denominator approaches 0, okay, that is the definition of the derivative. So the instantaneous velocity is the derivative of the position with respect to time, okay? And so as an example, let's say that we have this position as a function of time, okay? And it's given by 4.9 t squared plus 2t, 2.0 times t. And we want to find the velocity of the particle as a function of time. And then we also want to find what the velocity is at a specific point in time. So let's go ahead and do that. So all right, we have our position with respect to time, and again, we're going to assume the motion is along a straight line, all right? And so all I need to do at this point in time is to take the derivative of my position function, right? And if I take the derivative, I'm going to get 9.8 times t plus 2. Okay? So there are my, there is my instantaneous velocity function, okay? So again, to find your instantaneous velocity, all you need to do, if you have your position as a function of time, just take the derivative, okay? And now, to find the instantaneous velocity at 3 seconds, we just plug 3 into this equation. Okay? And so 9.8 times 3, 9.8 times 2 is 19.6. So this is going to be 29.4. And I'm being a little sloppy here, but we should note, okay, we did not give the units on these coefficients, okay? But what we should have is that the units on this coefficient should be meters per second squared. So that way, when we multiply by second squared, we'll just have length. And this should be meters per second. So when we multiply by time, we should just also have length as well, okay? So this should have units of length, and this should have units of length. We're assuming that our units are correct in this equation, okay? But at this point, okay, when we plug in 3, we're going to get 29.4 plus 2, which is 31.4. And the units on our velocity are going to be, well, if we're in SI units, and we assume we are, this will be meters per second, okay? So after 3 seconds, my object will be moving at 31.4 meters per second.